So what will be the ongoing sweet spots for 3D printing in the supply chain? By the way, when we say 3D printing and additive manufacturing, they mean the same thing. We really use them interchangeably, the two terms. So what will be the sweet spots for 3D printing in the supply chain in the future? Where does it offer the most value?
It's a good question. I think a lot of people have, different viewpoints. As a supply chain person, I see huge value in the front end. We call bridging solutions, right? And if you think of the product life cycle, the tails of the bell-shaped curve, if you will, development phases, it's just ideal because you can iterate, as we've talked about, design change after design change very, very rapidly and very inexpensively, as compared to injection molding, having to be able to chisel out those changes, if you will, in steel. And you say you want to obsolete a part as you're unsure of the design at the very beginning. When you don't have a $20,000 tool to obsolete, it's a lot easier to be able to throw away, a bunch of electrons. And then if you take a look at the back end of the life cycle, that's the opportunity, is to be able to, at end of life, after you've, we'll continue through the life cycle. So if you start off in development and you bridge, that's a term used to be able to get you into injection molding because of economics. And as you go through that peak life cycle in production, and you come back down the end of life, as the volumes start dropping down, 3D steps back in again. And it's kind of this hybrid model where you can jump back and forth to be able to support out the injection molding. And when you're in that end of life, in our business and injection molding at HP, we have hundreds of thousands of steel tools that sit on an end, specially prepared rims to be able to protect them from floods and earthquakes and fire. And then we have asset tracking on all of those. They all say property of HP, and they're coded. And there's a lot of resources that go into being able to make sure where those assets are around the world, so they can print the last 50 parts for end of life. So wouldn't it be nice if you could then use 3D printing to be able to have more of a virtual, digital, warehouse towards end of life? And that can work if you start in the very beginning of the life cycle with that endpoint in mind, so that when you transition into injection molding, you have and maintain the tolerances and the mechanical properties of the 3D product, so that it can do that again towards the back of life when we're at end of life.
Yeah, I think that you hit on most of the curve. I mean, if you think about the production curve for any product, obviously in the prototyping phase, 3D printing is going to continue to play a role. I tend to think of additive manufacturing as when you're doing production scale. That's kind of mentally what I associate with it. But like you said, Terry, it's synonymous. So obviously the production or prototyping phase, the aftermarket phase for on-demand parts, when the volumes have dropped down, continue to exist. Tooling and fixtures, can't forget those. Those are going to as an ongoing need, the ability to rapidly customize. 3D printing will always have a place there. The last place is obviously production. That's been the holy grail. And I think the important thing to understand about additive is the economics of it are improving every year. Especially in the metal space, if we talk about some of the binder jetting technologies that have been brought online, some of the wire fed technologies that have been brought online. In the metals world, that is driving costs down, and we're seeing in the polymer space, HP coming into market helped have a positive impact on driving more competition and better pricing for production scale. But again, typically, if you can make it another way, you're going to make it another way. The example is when you can't make it another way. And in certain examples, there are design concepts, and the GE Leapgen engine nozzle tip has been reused ad nauseum, but there are many others like that. You think about massively bespoke products like the acetabular hip cups and other applications like that, where you can only make it with 3D printing. You get a genuine improvement in quality and performance because of that. And that's where 3D printing will also have a place in those sorts of parts at a production level.
I think that ties back, Terry, to your earlier comment about part consolidation as another example of making the unmakeable, which is doing things that you couldn't do with traditional technologies. And I think we are seeing examples where companies are embracing these in the millions of units, and Carbon and Adidas and their collaboration is well known, and those are high volume in the millions of units. We at Fast Radius announced a collaboration with Ford and Aptiv, where we're making high volume electrical connectors that are going out into the cars. And so this is now possible. Economics are making sense for these type of volume applications, but it does have to be coupled with a quality system that companies can rely on to make sure the parts we make today are going to be the same as we are there 10 years from now. I would also, picking back up, Mike, on your comment on the virtual warehouse, we're proud of the collaboration that we've had recently announced with Airbus and Satair to create a virtual warehouse for aerospace tools. And we work with our friends at HP on a number of these parts. And we've gone through, Mike, as you commented, upfront a design exercise to say, all right, let's design these tools with an eye on how they can be made and stored digitally. Now, they also embrace, in some of the parts, traditional technologies like machining and molding as well. So it's a system that comes together, but all of that can be done in an on-demand way. So now at Fast Radius, we have thousands and thousands of parts in our virtual warehouse. Mm-hmm. And as we reflect on the pandemic, and these are certified, PPAP approved, customers can count on them being reliably made the same way now or 10 years from now. Unfortunately, as we looked at the pandemic, in that virtual warehouse, we didn't have ventilators, we didn't have swabs, we didn't have many of the components that were in critical need. But fortunately, now we do. And as an industry, if we look forward over the course of the next decade, imagine what this virtual inventory is going to have in it to serve future challenges that the world confronts, whether that be from a health pandemic or natural disasters or new opportunities that are ahead of us. And I think that's what, for us, gets us so excited about the need to continue building this industry so that we can serve the needs of the world and our communities better.
Yeah, that's great points. And one last thing, Terry, I'd love to add, if I may. I didn't mean to pigeonhole too much the production case for 3D printing to just parts that can only be made by 3D printing, because there's a very important secondary scenario that we see commonly, and that is flexibility. When companies are looking at production volumes, but they're not entirely sure, like I was saying, with that band, if you know that design is locked, injection molded, if you know the demand is there, but with a bunch of people flooding into the market, a lot of companies say, well, I don't know if I want to tool up for that. Instead, I can continue to manage my batch orders, I manage my material loads, I manage a lot of things, and I de-risk my production application by sticking with 3D printing. And maybe I give up a little bit on a per unit basis, but I don't have those big upfront fixed costs. And I think as companies and their supply chains become more nimble, we'll see more of this, where companies say, yeah, we iterate faster through product revs, and we use 3D printing as our go-to production, even though we could make it another way.
You know, it also makes me think about the flexibility. Oh, I'm sorry, Terry.
Go ahead, Mike.
No, I was just going to say, you talked about flexibility, Cullen, and that made me think just while we're in production, right? If you compare it to injection molding, to be able to, if you have a problem with a particular supplier or a particular tool, right? That machine goes down, that tool goes down, it's a very unique fixed piece of asset. And with 3D printing, when you talk about flexibility, I can now just pick up the phone and say, hey, Lou, can you guys start printing this part for me? And they can do that tomorrow. If they've got an open machine, they do it immediately. There's no transfer of a piece of steel, right? So that opens up the possibilities from a supply chain perspective, opens up the possibilities to be able to respond to national crises, right? Where you've got this flexible capital that you're able to turn on and to redirect from making automotive parts to PPE, literally as soon as the machine opens up, versus having to be able to, have that fixed asset wrapped up, or your capital wrapped up in that fixed asset of an injection molding machine or tool.
Yeah, agree. Lou, I was going to ask you about the work with Airbus, the virtual warehouse that you helped them build. Is that for maintenance and repair?
It is, Terry. It is a library of tools that have been engineered and validated to help get the planes in the air again. And so a range of tools and fixtures that are a part of the maintenance of the aircraft.
I remember Donald Godfrey talking about the work at Honeywell Aerospace and how to keep airplanes in the air, they're willing to spend a lot more on a part, and so you can justify, maybe the traditional manufacturing cost on a given part or assembly. We'll just throw out an arbitrary number of $1,000, but they're willing to spend many times that because of the cost of that aircraft sitting on the ground. And
right on.
Are you seeing the same thing with Airbus?
We are. There's a willingness to pay there because of the value that is unlocked, and you also don't have the lead time, and you don't have, as Mike said, injection molded tools sitting on a shelf, and it gives incredible flexibility. I think the other thing is that we've designed many of these parts so that you're consolidating complex assemblies into single or components that are actually built as a single unit, but they can adjust with living hinges or threaded components that you can build as a single component that allows you to achieve the performance that you want in an integrated tool, unlocking the benefits that additive can provide. And so I would highlight that it does take effort to engineer and design these tools, and I compliment our colleagues over at Satair and Airbus. They see the long-term impact here. Now, the library of tools that we now have, they're there forever. And as much as we can scale up and down every day, depending on what the needs are in the market. But it does require that upfront learning and investment in designing of these tools.